Swayam Prabha. Digital India. Educated India.
Let's begin with the scanner system. Okay, so how scanner works now. Okay, so as you can see, you'll have a computer, then you have a connected scanner to it, and then the scanner will have like a lot of these elements of mechatronic system that we have seen. So there'll be actuator, there'll be a scanner head, and then like as a plant, then you get something from the scanner head, which is like the line scan, like image. With the image sensor, you get like actually the image of the page, and that goes to microcontroller. But again, here is this image a feedback? Probably not. Okay, so we'll see what is there any feedback or required in the first place or not. Okay, all those kind of things now we will start looking at. So it's also a very interesting system for scanning with the color scan. Of course, nowadays you have your mobile phone. You can directly use this scanning application, and like your scanning of the documents can be done with simple mobile images and things like that. But for xeroxing purposes and for scanning purposes, okay, so this now a lot of these sophisticated systems have come with much more automation than what you have in the scanner that we are going to see. Okay, so what we are going to see is a simple scanner where you have, like, let me see this picture here. Okay, so let's see the picture first, and then so this is a kind of a scanner we are going to see. Okay, so it doesn't have any paper feeding system or auto kind of scan of any entire document kind of a stuff. Okay, which is there in not a lot of modern xeroxing and or photocopying, to be precise, and scanning systems. Okay, so again, our goals here are similar as we had for the CD-ROM system. So given a problem, how to synthesize a mechatronic solution, you need to have a thinking done. Now that we are equipped with a little more kind of knowledge based on the CD-ROM drive, one can think for the scanner kind of very easily, probably. Okay, then again, thinking in both like multiple domains together, and see whether there are any kind of solution that we can give mechatronically in this kind of a system, and again observe other solutions that people have given in the these professional solutions that people have given for such a system, and learn from it. Okay, this is kind of standard process that again we'll go through. So what is the problem at hand now? So this problem is simple. So function of scanner, you all know that, okay, you have a page, and page has some kind of color and maybe black images, black parts in the image, and that image we want to kind of have scanned and converted into a digital format, which will be displayed on your computer, or it can be used for many other purposes. Okay, so and typically the data in this is read line by line. We are not taking a picture immediately and using that picture as a scan data. Okay, so this will have a much more higher resolution of image that can be possible with the scanner. Okay, that is what we will do here. Okay, and to get that, now can you think about, pause here and think about, okay, what solution comes to your mind? Okay, based on whatever scanner use that you had already done, what is the kind of systems that this scanner needs to have? It's not very difficult to think, like one can know that, okay, I need to scan a page with the some kind of a sensor. Okay, so the head should move across the paper in some way, right? That is clear. That so that some kind of a motion system should be there which can move the head of a scanner on the surface of a paper. Okay, and as it kind of moves the head of the scanner on the surface of paper, it should scan line by line. Okay, the data should be getting line by line. The data should come into the now what is this data? How do you kind of get this data? What kind of sensors you should have to get this data? Can you think about? Okay, so they need to be something like a light sensors. Okay, so how this light sensors will be doing the job of sensing and doing this kind of a scan. So this is what you need to think about and see, okay, what is a way these light sensors can be employed to kind of register the data across one line in one go, probably, because you move this head on the surface of a paper and read one line, next line, next line, keep on reading like that as the paper is moving. Okay, so the speed of motion of the head will be governed by how quickly you are able to kind of register the data for single line scan. Okay, so let's start looking at it again. So these are the questions that we raised: how the page is scanned, okay, and what are the sensors, actuators there. What is a sensor that converts the paper into digital kind of a form output and still preserves the color, and the sensor width now needs to be same as paper width or no? Okay, think about this. Okay, so one can easily see some kind of a solution can emerge for the head to move, that we can use some stepper motor as we have seen in the CD-ROM drive. Now, do we need, what is the accuracy that is needed again here? If you want to think about what is the accuracy that is needed for the motion here, okay, so that is not as fine as you have seen in the CD-ROM drives. Okay, so probably for this application you don't need to employ any compliant mechanisms. Okay, is that make common sense? Okay, yeah, the accuracy may not be so high, right? So so we'll see how this accuracy can be see whatever this kind of accuracy that is needed, that is achieved, but it will not be definitely very high in nanometric position. It may be some 50 micron, 100 micron kind of accuracy you can be okay with. In one particular kind of a direction, if you keep on scanning, then that there is no direction reversal that is happening here. There is another thing to note, okay, that I start scanning, I don't have to reverse the direction anytime. You can see that, unlike in CD-ROM drives, my head can go forward and backward as it scans the entire surface of the CD. So I need to be able to kind of move both backward and forward there, but in the scanning I just move only in one direction. Okay, during the scan. Once the scan is complete, of course you come back to the normal position and continue whatever next scan. So let's kind of start with the seeing the scanner first. Okay, and open up and see. Okay, see, when you open up the scanner and see, just cover opening, and through the glass you can actually notice you have this black kind of a head here. On that is a white line. Okay, what is this white line for? Okay, what is there inside this box that is doing the job? Then you see that there is a flat kind of a connector which is running from here to here, and as the head moves, this flat connector kind of folds and doesn't give too much of a disturbance to the system or motion of this black head. Okay, and then there is a small little kind of a circuit up here which kind of gathers the data and communicates it to the computer. Okay, so let us open further, okay, and see what is that we get now. Okay, so what we need to observe is what are the different components that you can find and identify what are they for. Okay, out of that, these are the two systems that we talked about. One is motion system, and other is sensing the sensor system. Okay, so and then see the guide guiding in this case, how this guiding in this case, now can you relate this whatever guiding is happening in this case to what we saw in the CD-ROM drive. Okay, so let us start looking at these questions here. So as you open up the top cover here, okay, there are some screws which have to be removed from the top cover here and here, and you'll be, and then some kind of a mechanical interlocks will be there, and you'll be able to open this. Then you can observe there is some kind of a drive system here. Okay, typically this has a stepper motor. Why stepper motor? Because if you see on this motor also, you'll observe there are 4 terminals that are coming out. Okay, then there is some kind of a gear system. We'll open up that and check what is that gear system. And then there is some kind of a drive here. So this belt runs over the entire kind of the wheel up here, and then there is some kind of idling wheel up here. Okay, and then this head is guided by this guide rod. Okay, this is a steel rod which will guide this head here. And then where is the other guide? There is only one guide here. Okay, let's think about where is the other guide. What is acting as other guide? Can you notice something in the other side which will make sure that it is guided at 2 guides, and it cannot have just one single kind of a guide. Okay, so what is that guide on the other side is what you need to think about. Okay, let's proceed further. So this motion, as you see, is in this direction, and then this is like a very bright mercury kind of a lamp here. Okay, mercury tube here, very thin but very bright mercury lamp. Okay, and then for this lamp to be driven, you need a good amount of current, so that these wires, if you see these white wires that are going to the circuit, they're quite thick. They are not very thin wires there. Okay, the thick wires are needed for the higher currents that are to be carried to the tube. Okay, now what is inside this black box? It looks like a black box. It's really a black box to see, and then we see what is there in this box to kind of can you imagine what is there, what could be there inside? So let's see. So this, first we observe these guides. Okay, so these are the guide. This is one guide for the motion system, this rod that we have seen. Okay, so here it goes inside, but inside we'll show later that it is actually guided by at 2 points. Okay, so 2 points it is going through as we have seen in the CD-ROM drive system. On one side it goes to these 2 side supports. Why that is needed? Because, okay, think about that. Okay, you think about that. Why you need a 2 points? Okay, even if it is guided here, it will be, yeah, this is the other point it will be guided. Okay, so observe carefully that there is some kind of a small protrusion coming out on the surface of this bottom. Okay, that protrusion is actually guiding, it's kind of a resting. This system is resting on this protrusion by gravity. Okay, you don't have, if you lift it, it will kind of get lifted up, but I mean, there is nobody to lift it when it is all packed and covered system. Okay, so then it will not have much of a problem. So there is no like a rod kind of a guide, but it's just a small protrusion that is coming out. They have saved the cost of the rod and assembly, okay, by means of this kind of a protrusion, which is sufficient to make sure that it is guided on the other side also very well. Now this is fully guided, means it is having a rod fully covered on all the sides by a guiding sleeve. Okay, and this is not on somewhere here. Okay, it is on this side. Okay, so why this guide rod on this side, not on the opposite side? Okay, you may say, okay, oh, there is a circuit on this side. Okay, no, I could have circuit on the other side, on somewhere in the middle. I mean, there is a space up here, whatever. I can have circuit on wherever I want. Okay, but there is a specific reason for this rod to be on this side, particularly close to this motor. Okay, close to its drive. Okay, think about that. Think about a free body diagram when the motor starts operating and starts moving this head. What are the forces and moments that are coming on the system, and then you may understand this part. Okay, if you see this motion system a little bit more in details, like if you see this motor here, you remove these 3 screws, and like you'll see that there is upside down. You can see there is a motor which is driving a gear, a pinion, which is like with the gear reduction driving this this wheel, which is on which like this belt is going. Okay, so this is a two-thread wheel on which this two-thread belt is mounted, and that belt is running all across the drive, and there is something like a spring here. Okay, what is this for? Okay, so think about it. This is like if you see that this is a kind of a spring, and then like the belt goes inside that, and like it is, when you straighten the belt, it will have some kind of a tension. Okay, so these are questions that we need to kind of address here. Now is there backlash compensation in this system? Okay, we don't see it here. You cannot see that okay, there are 2 gears which are like spring loaded or something like that. So is it really required there? Okay, so it's probably not. Can you think and justify why it is not? Okay, because you don't have a very high precision positioning system here, first thing. And second thing, like once you start driving in one direction, you are not going to reverse the direction at all, right? So you keep on driving in one direction, so then there is no backlash question comes in there. Even if there is a backlash in the system, it's not going to harm your application. Okay, so you see that it's very interesting way, like that okay, this backlash doesn't bother for this application. Okay, so you don't have to kind of compensate for backlash for everything, like only where like you have to make sure that okay, the application is requiring this need for compensation of backlash, then only you need to do that. Okay, so okay, another thing, why there is a two-thread belt here? Okay, one could have used like we could have used here a normal belt also. Okay, why two-thread belt? Okay, so this belt will make sure that it will not slip. This belt will not slip from the motor, and there'll be like when the motor is driving, like it's a positive drive that will happen to the system with the stepper motor. Okay, okay, so in case of trouble where like the head gets stuck in this particular case, then what will happen is like stepper motor will start losing some steps. Okay, and there might be some way electronically to detect that okay, the stepper motor is losing some steps. Okay, another thing you might notice here, that okay, in the entire system, if you have opened up and seen, like there is a motor here, but on the motor there is no sensor. Okay, typically like you'll find otherwise like the additional kind of a sensor sitting on the top of the motor, and neither there is a sensor in this belt or any other place for the motion sensing. So why there is no need for the position sensor here? Okay, if you ponder over like little bit, you'll find it okay, oh yeah, there is no need for the motion sensor, because as you start like saying like operating motor in one direction, okay, it starts scanning, and then as it continues like its motion with the we know the number of steps that are given will be proportional to the position of the head. Okay, in one particular direction. If I keep on driving in the same direction, exactly that number of steps that are given will be equal. Now when I reverse the direction, then my count may not match. Okay, because of the backlash in the system. Okay, so that's where like this is elegant kind of a way they have eliminated the the sensor in the system. I keep driving in one direction, and like I get to know. Okay, now where to start, like this is a starting, there is a, for starting to know where to start, like there is a small limit switch inside the thing. Okay, so that limit switch, I don't think I have a photograph of it, but there is a limit switch inside the head somewhere, okay, which keeps on doing the sensing of the data. Now so this little thing here that you see with the spring loaded is it's for the tensioning of the belt. Okay, so you can see the tensioning of the belt here. Okay, so when this tension is released, like this spring kind of gets no tension inside it, but if you see this stretched belt is stretched, like no spring will be under tension here. Okay, so this is the thing that you can observe here. Okay, you observe. It's interesting kind of a mechanism to kind of make sure the belt is tight, so that like a small amount of backlash at least will be taken care of in the belt. It's not a like no backlash, sorry, it's a slack in the belt. Okay, so otherwise the belt being so long, it will have a tendency to slack. Okay, and then also like if you see this is very interesting way the manufacturing errors in the assembly would be taken care of. Say for example, if the motor is mounted little bit here and there, okay, in position, the belt will not get slacked. Okay, the belt tension will be maintained by using the spring, and this will be very nicely, it will kind of operate, and belt is kind of firmly held to the head in this particular place here, and next to it is a spring. So the spring will not come into the, it will not go ever over the pulley. Okay, the spring part of the portion of the belt will not ever go over the pulley. Okay, so then like so you have this one continuous belt, and it is spring loaded here, so it's spring tightened here, and even if you have some errors in the assembly of your motor, they are not going to be your belt is not going to go slack. That's what is made sure because of this kind of a interesting way of doing things. Okay, so the accuracy or the skill that is required in assembly is avoided here. Okay, now this is another kind of a you see the similar subsystem for scanning. This is in the printer. Okay, if you see printer on the top, there are some printers with the scanner like combined system is there. So in that system we will have this kind of arrangement. This is another kind of a scanner opened, I would say. Okay, so we have seen these are the subsystems so far, like scanning head subsystem and sensor for recording the scan, and then you will have data communication plus head and control systems and things like that. Okay, so now let's move on to this second system, which is a sensor system. Okay, so if you see this black box opened, okay, you will observe all these kind of elements. Can this make sense? Okay, so you see that there is this big size something glass kind of a thing here, and then there is some other kind of a glass kind of a thing here, some other kind of a thing here, then similar kind of a thing here, and how do you kind of make sense of all these things? So if you see carefully, these are like if these are not just glass, but they are kind of mirrors here. Okay, if you carefully observe them, you'll see that okay, they are actually mirrors. Okay, and this is the first mirror, which is like length of the paper size mirror. Okay, then there are subsequent mirrors which sizes are like smaller and smaller. This is a smaller mirror, then this is a smaller mirror, like that there are smaller and smaller size mirrors that are happening. Okay, so if you see their angles at which they are placed, then like you see that okay, the one mirror reflects on the surface of other, and like and so on and so forth. Like okay, so so image is full length of a paper image which is coming on the top surface of the, imagine there is a glass, we have removed that glass. So from the glass, the whatever is written on the paper will come as a reflection on this surface here, and this mirror is at some angle such that like this reflection comes on the surface here first from the top illuminated by UV or like that mercury lamp, and then it will get reflected on this surface. So this angle is such that the mirror this reflection of this image of the paper like goes here, then from here it goes to the next mirror here. Okay, so you see this is smaller mirror than this mirror. Okay, then like you'll have a further smaller size here. Okay, and then from here further smaller size it will go on this mirror, and from here this is like about an 45-degree angle, so it goes down from here. Okay, like that. Okay, now we'll see what happens when it goes down. Okay, so there is some other kind of a system that is expected down there. So this is what is there in this kind of a black kind of a box that you are, or black head that you are seeing for this system. Okay, so this is a reflector system for the optics. Okay, and you can notice that every time it getting reflected, there is a reduction in the size happening. That means are we losing the image here? No, 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 we are not losing the image. What these mirrors are, they are not like a normal mirror, they are like a concave kind of a mirrors. Okay, so they'll kind of sense the larger size and focus it on the next mirror in a smaller kind of a size. Okay, because they are concave kind of a mirrors. Okay, so that is what is important here to see. Okay, that is what it means, that every mirror is a concave mirror. Every time the reflection happens, the size of the whatever is reflected keeps on reducing. Okay, why would the size reduce, or why it is needed to be designed that way, we'll see. Okay, so what happens to the system next? Okay, you come down. Okay, this is now upside down here. Okay, when you see upside down, this is a mirror which is receiving the input from what the arrow that pointed down there, so it is coming up here. Okay, because it's image taken from the bottom side, and now there is a final kind of a concave focusing happening into this system. This is a lens here. Okay, this lens would look something like that. Okay, if you see, this is the image of reflection from this final mirror will get onto the lens, and it will create an image on the sensor. So this is a virtual image that will get created on the surface of a sensor. The sensor is located up here. Okay, so this is a sensor in which on which this mirror, the image gets virtual image will get formed on the surface of the sensor. Okay, so far so good. What you see here is this little circuit which actually drives the mercury tube that we have seen, that white light kind of a tube there. Okay. Now we further open up this. Okay, you open up this lens and open up the sensor, things will look like this. Okay, so this is a lens up here. Okay, this was a PCB that I was talking about for the light things, and these wires are kind of thick wires which are for high current carrying capacity. So this wire one goes on this side, another goes on this side to connect to the mercury lamp. Now what is there inside this chip? Can you imagine now? Okay, what could be there inside this chip? Okay, so think about it. If you observe under microscope, okay, this is the first kind of a image, or this is like not a microscope, but this is like a zoomed image of this sensor. Okay, you see some kind of a big line here, and then there are some wires that are connected, and there are these golden pads are like basically the points where the wires are connected. From these points, the chip carrier, okay, this package has these pins. Okay, so these pins will be connected finally to these small little pads that you see there. Under microscope, we need to observe the sensor to kind of really make sense what is happening there. Okay, so let's kind of do that. So if you see this image under microscope, you'll see that these are the golden pads which are seen up here on one side only. Okay, these other golden side pads are not in this zoomed microscopic image. And you'll see these are the wires that are coming to golden pads from these different parts of this main sensor strip. This is like a main sensor strip. Okay, on which you see there are some sensors elements start up here. Okay, so this is a part where the connections or contacts are made for electrical elements, and then there is a sensor pad that is up here, and other end of the sensor pad we can see here, and is under microscope again there is one wire. There might be multiple wires connected on the other side, but there are some circuits up here which are doing some local processing of the signal before it is taken out of the sensor from these wires to the PC. Now if you zoom in this area further, you'll find there are these red, green and blue parts here. Can you imagine what are they? Why there are red, green and blue parts, and below that there will be probably the sensor elements. You see these small like the lines here or dots there, they are like a sensor element, and the sensor element is covered by this red kind of a patch. Okay, and then there is a green patch and there is a blue patch. Okay, so these three sensing tracks, okay, will get from the image these three R, G and B parts of the image. Okay, so the big illuminated image is falling on this surface here of these three tracks, and like these are the three filters which are filtering like the image to kind of get R, G and B parts of the image saved, so that we can reproduce the color for the image in the nice way. Okay, so this is a arrangement for getting like the colored image very nicely done. Okay, so this is what is making like the colored image sensing possible. Okay, so then finally you will have this PCB for control and like communication. Now control in this case is not really a closed loop control, it's like an open loop control. You just keep on sending these the steps of drive to the stepper motor, and stepper motor keeps on like going until the end is hit. Okay, until the paper end is hit. So you have seen, you might have seen like in in this kind of a scanners, even if your page is half, okay, the scan is still made full. Okay, you cannot control that. Okay, oh, I want to scan only some part of the page. Okay, what is the reason? Because they don't have a sensor to kind of sense where the page is ending. Can you see that? Okay, so that's the reason like you don't kind of have a scanners to typically have scanning for this kind of a simple scanner. There might be some sophisticated scanners which might have like a little more kind of flexibility to kind of control where you want to have exactly the scan. But typically you'll find that okay, even if you are scanning, you say your passport, okay, you need to typically run this full scan, and then like once the scan image is there in the computer, then you kind of crop that image and like remove the part that you don't want. But as a scanner like has no smartness to kind of register that okay, only this part of the image is to be scanned and like given to you. Okay, so that is how like the scanner works. Okay, so again here you can list down your summary lessons here.